Hello. This video is for IXL, Activity 8.W.10. It is titled Solve Equations Involving Like Terms. And the three-character code for this activity is Quebec 2 Bravo. So combining like terms. We've done this before in an activity where all you had to do was combine like terms, and now we're involving this into equations. Probably one of the reasons why we learned how to combine like terms in the first place. So we're going to take that idea of combining like terms and then solving equations and go ahead and find the solutions for those type of problems. So for our first one here, we have 6y plus 3y. So rewrite the problem, 6y plus 3y. And this equals 18. So we're going to go ahead and combine the 6y and the 3y because they are like terms. They're both in terms of y, so we can go ahead and combine them. Well, if I have 6y's and I have 3y's, then altogether I would have 9y. And we'll bring down our equals 18. At this point, we just have a one-step equation, right? We need to go ahead and divide in order to undo the multiplication. We're going to divide by 9 because that's what's tied to the y. And so the 9's will cancel each other, leaving us with y, and 18 divided by 9, well, that's 2, so y equals 2. Now we could plug that in and find out if we plugged in a 2 here and a 2 here, and we had 6 times 2, well, that's 12, and 3 times 2 is 6, and 12 plus 6, does this equal 18? Indeed it does, so our answer checks out, so we know that our solution of 2 is correct, right? All right, moving on to the next one. We have 12g minus 10g equals 16. So if I have 12g's and I take away 10g, what am I going to have left? Well, hopefully you're saying, well, I'm going to have 2g left over because 12 minus 10 is 2. So I've got 2g equals 16. Now I need to divide, right, to undo the multiplication here. So I'm going to divide by 2. And what I do to one side, I need to do to the other. 2's are going to cancel each other, leaving me with g, and 16 divided by 2 is indeed 8. So our solution is 8. Here we have 13y minus 10y plus 5y equals 8. So I could rewrite it, or I could just kind of start working it from here. And if I took 13, because I have 1, 2, 3 terms that are all in terms of y, right? Remember counting the number of terms. We've done that in activity before. So I have 3 terms here on the left. They are all in terms of y. So I could do the 13 minus 10. Well, that's 3, correct? And then if I add 5 to that, then I end up with 8y. So combining all these terms together, terms of y together, gives me 8y. And then bring down my equals 8. My only thing left to do now is to divide by 8 to isolate that variable y. The 8's will cancel each other, leaving me with y equals, and 8 divided by 8 equals 1. So y equals 1. On the next problem, we have terms of a here and here. We have 2 terms that are alike. So 2a plus 2a, well, if I double that, basically, I end up with 4a. Now let's bring down the plus 1 and equals 13. So I'm down to a 2-step equation now. I need to first subtract 1 from each side so that I can get that 4a by itself because those cancel each other. And 13 minus 1, well, that's 12. The next step is to divide by 4 in order to isolate the variable a. The 4's will cancel each other, and I'm going to end up with a equals, and 12 divided by 4 is indeed 3. On the next one, wow, a whole bunch of terms of m. Looks like 1, 2, 3, 4, 5 different terms of m. Now, be careful here because there's no value here in front of this m. There's no leading coefficient. But we do realize that there should be, we could put a 1 there and it wouldn't change it. So we do realize that we have 1m there. Another thing to look for is look for opposites. So I have 3m here and 3m here. Well, those are going to cancel each other out, right? So I can get rid of those. And then I have, let's see, I have a positive 11 and negative 5. Let's go ahead and put those together. This here and this here together, well, 11 minus 5 is going to be 6. And that's 6m. And I still have this 1m here. So I'll go ahead and bring that 1m down for now. And, oh, I almost forgot something. Missed that plus 4 there, right? 1m. And let's go ahead and combine these now at this point here. Let's just go ahead and make that 7m. And now let's go ahead and bring down our minus 4. So all this here got us to this point here, and equals, and let's bring our 10 down. So now I need to add 4 to each side, right, to get rid of this negative 4. Remember what we do to one side, we do to the other. The opposite's going to cancel each other out, leaving us with 7m, and 10 plus 4 is going to give me 14. Now my next step is to divide by 7 so that I can isolate that variable m, and those 7's will cancel each other out, leaving me with m equals 14 minus, or 14 divided by 7, not minus, equals 2. So m equals 2 in this case. On the next one, combining a bunch of like terms here. So let's work with, well, check this out, 19 minus 20. That's going to give us a negative 1, right? So then we add 7. So negative 1 plus 7 is going to give us a positive 6. And then we add that positive 12. That's going to give us 18. 18 what? 18n. And then equals, bring down our negative 18. Next step is to divide by 18. So we're going to divide by 18, and I'm looking at that negative over there, and I'm getting ahead of myself. So I'm going to divide both sides by 18 because the 18 is tied to the end through multiplication, and the opposite operation of multiplication is division. I'm dividing by the very number I wish to get rid of, which is 18. So the 18s will cancel each other, leaving me with n equals, and negative divided by positive equals a negative, and 18 divided by 18 is 1. And so I have n equals negative 1. Now we have all terms of k. And I'm looking for ones that go together well. And let me see. I'm not really seeing the 3 and the 7. That's not going to make 10. The 26 and the 7. Let's just work it from left to right. We'll go that way. So 46k minus 26k, or 45k. 45k minus 26. So we're going to need to go ahead and subtract that. So let's make this a 15, and we borrowed, so that's a 3. And 15 minus 6 is 9, and 3 minus 2 is 1. So at this point, we're at 19k, right? Now we're going to add that 3k there. 19 plus 3 is going to give us, 19 plus 3 is going to give us 22, right? Pretty sure? Yep. And now let's go ahead and subtract 7 from that. 22 minus 7 is going to give us 15, right? 15 what? 15k. So after combining all these, we did the 45 minus the 26. We got to 19. We added the 3 to get to 22. Subtracted the 7 to get to the 15k. So 15k equals, and let's bring down this 30. Now we need to divide both sides by 15. All right, remember what we do to one side, we're going to do to the other. The 15s will cancel each other, leaving us with k, and 30 divided by 15 is 2. Therefore, k has a value of 2. Wow, whole bunch of stuff across here. So let's identify all of our terms of a. Looks like we have 4 of them, and then we're going to have that minus 6 we'll bring down later on. So I'm looking for ones that go together well. I don't really see many of them. So let's start with, let's just go left to right again. Let's go the 36, and we're going to add negative 65. So if we add 36 plus negative 65, remember we're adding a positive and a negative number together, so we're actually going to subtract. We're going to do the 65 minus 36. I'm going to need to borrow, so it's going to become a 5, and this will become a 15. And so we have 9, and 5 minus 3 is 2. So at this point we have 29. Oh, is it positive or negative? This should be a negative, right? Because the 65 is the greater absolute value, and it's negative, so our answer is going to be negative. So we now have negative 29, and we are going to subtract 15, or that is to say we're going to add a negative 15. So at this point here, we have a negative 29 plus a negative 15, and we know that they're both negative, so it's going to be even more negative, so we actually add those together. 29 plus 15, well, 9 plus 5 is 14, carry the 1, and we have 4, so we end up with negative 44 at this point. So now we're at negative 44, right? And now we're going to go ahead and add 27, so a whole bunch of integer addition here. Negative 44 plus 27, so we're adding a positive and negative number together, so we're actually going to subtract. I'm going to take that 44 and subtract 27. And let's borrow. That becomes 3. This is going to become 14. And 14 minus 7 is 7. 3 minus 2 is 1. So we end up with 17. And right here in this, where we had that negative 44 plus 27, the negative 44 has a greater absolute value, and it's negative, so our answer is going to be negative as well. So that's negative 17a. Well, a lot of work to get to negative 17a. We still need to bring down the minus 6. Actually, let's make that a plus negative 6, right? Same thing. Equals negative 57. Now, we need to add 6 to get rid of the negative 6, so plus 6. And we're going to add 6 over here. So those are going to cancel each other out. We'll have negative 17a equals, well, we have 57, negative 57 plus 6. So we're adding a negative and a positive number together. So we know we actually go ahead and, lost my train of thought there. We actually got to subtract those. So 57 minus 6, and that's going to equal 51, right? So is this a positive or negative 51? Well, hopefully you're saying it's negative because the negative 57 has a greater absolute value. So our answer is going to be negative, just like the negative 57. So we end up with negative 51. And I'm assuming that's going to be 3. We should come up to 3. So we're going to divide. And you're wondering, what do you mean 3? I'm actually working the problem out in my head already. So I'm going to divide by negative 17 on both sides. The negative 17s are going to cancel each other. And I just get a, and then negative divided by negative is positive, and 57 divided by 17 is 3. Just to be sure, 17 times 3, and 1, 2, and 3, 5. Indeed, it is 51. So a equals 3 is our final answer. Okay, last 2 questions here. Going to go through all these W's here. Looks like 1, 2, 3, 4, 5 terms of W. And I'm looking for ones that work nicely together. Let's try another strategy. Look at all the negative values of it right here. So we could add all these negative values together. 46, 18, and 8. We just stack all those up. We know we're going to add those, right? So we have 8 and 8, 16, right? Add 6 more. That should be 22, right? 16, yep, 22. And carry the 2. So 2, 6, 7, we have 72. So this is a plus negative, right? They're all negative, remember? Negative 72 W. Now let's put these 2 together here. 77 plus 5, what is that? 82? So we get 82 W and equals 70. So we've combined all the positive W's together, combined all the negative W's together, and now we need to combine the positives and the negatives together. So now we have 82 plus a negative 72. So since we are adding a positive and negative number together, we know we're actually going to subtract. So we do 82 minus 72, and that's going to be a difference of 10, right? And the 82 has a greater absolute value than the negative 72. So since the 82 is positive, our answer is going to be positive. So we have 10W. And this is going to work out real nicely. Equals 70. Now let's divide by 10 in order to isolate that variable of W. And what we do to one side, we're going to do to the other. And the 10s will cancel each other, leaving us with W. And 10 divided, or 70 divided by 10 is indeed 7. So W equals 7. On the last problem here, we have 20 minus 17. Like, gee, this is supposed to be more difficult. Actually, you'll find sometimes in the IXL activities, you'll get up in the 90s and you'll have some really hard questions. And all of a sudden, that last 99, to get from 99 to 100, it's like a really simple question. So here we have 20y minus 7y. Well, 20 minus 7 is 13, right? So 13y equals 78. And so let's divide by 13 to get that y by itself. That is to say, isolate it. And the 13s will cancel each other, leaving me with y. And 78 divided by 13. I'm thinking that, will 6 work? What's 13 times 6? 18, carry the 1, 6, 78. Indeed it does. So it's going to be 78 divided by 13 equals 6. So our correct answer is 6. So there you have it. Pretty much combine the like terms, and we're taking a couple activities that we've done before of combining like terms and then doing multi-step equations, kind of putting all that together, and it shows up in this activity here. For the most part, after you combine like terms, most of the time we're not really ending up with anything more than a two-step equation once we've combined the like terms. So I guess combining the like terms is a step within itself also, so it could be considered a very multiple step equations, but nonetheless. So those are all my examples for IXL 8.W.10, solve equations involving like terms. Good luck on your activity.